How do rocket engines work? Well, first you need fuel and oxidizer, the stuff that makes the explosion. For a long time, rockets use a combination of liquid hydrogen and liquid oxygen. But newer rockets use other chemicals like methane and oxygen, or even methane and liquid nitrogen. Then you need a way to mix the fuel and oxidizer in just the right way and at the right time. And that's done by the engine's complex plumbing, including pipes called manifolds. And once the fuel and oxidizer are mixed and ignited, they burn fiercely in a place called the combustion chamber. What's amazing about these engines is that everything happens in a fraction of a second, the fuel. And oxidizer must be delivered to the combustion chamber under very high pressure. A typical rocket engine might operate at about 250 bars, which is 250 times the air pressure at sea level. This requires pumps that spin at over 10,000 revolutions per minute. Once the mixture is ignited, the result is an extremely hot expanding gas. Imagine blowing up a balloon full of hot air and letting go. In the case of a rocket engine, though, the balloon expands and exhausts out of the back, shooting the rocket forward with tremendous force. The gas flows through a narrowing pipe called a nozzle that accelerates it to supersonic speed. The faster the gas flows, the more thrust the rocket produces. In fact, the shape of the nozzle is critical to the engine's design. A well-designed nozzle will expand the gas to just the right amount, converting as much of the gas's pressure into thrust as possible. Anything left over gets pushed out the sides of the nozzle and wasted. And that's Newton's third law of motion and action. For every action, there is an equal and opposite reaction. As the gas expands out of the back of the nozzle, the rocket moves forward. There are several different kinds of rocket engines. Early engines were relatively simple, using a gas generator cycle. These engines used some of the fuel to spin the turbopumps, while others burned extra fuel to produce the thrust. More advanced engines use a staged combustion cycle. In this system, all of the propellant is burned, so the engine is more efficient. The space shuttle used a staged combustion cycle, as did the old N-1 rocket, which was designed to take people to the moon. The next evolution in rocket engine technology is called full-flow stage combustion. This engine feeds all of the fuel and oxidizer through the combustion chamber, meaning nothing gets wasted. SpaceX's new Raptor engine uses this method, making it one of the most efficient rocket engines ever built. Rocket engines are also being improved to make them more efficient. One promising design is the Aerospike nozzle. This nozzle expands and contracts as the rocket ascends, making sure that more of the gas's pressure is converted into thrust. Another way to improve rocket engines is to find new propellants that burn more cleanly. Some of the chemicals used today are highly toxic, which makes them hard to work with and expensive to dispose of. But new propellants like methane are less toxic and could be produced on other worlds like Mars. In fact, reducing the weight of rocket engines is always a top priority. After all, every pound that a rocket takes off has to be hauled back down again. That's why SpaceX is 3D printing entire rocket engines. In the future, composite materials could replace heavy metals, reducing the engine's mass without sacrificing strength. Of course, the biggest limitation to rocket engines is that they're heavy and complicated. But new designs like ion engines could change that. Ion engines are powered by electricity, meaning they could be much lighter and simpler. Someday, they could even be powered by solar panels. Nuclear thermal rockets are another possibility. These engines use a nuclear reactor to heat a propellant like hydrogen, although nuclear thermal rockets have never been deployed in space. They could one day be used to deliver cargo to other worlds quickly. And if that doesn't sound exciting enough, consider fusion propulsion. This method uses the heat from nuclear fusion to propel a rocket. But fusion power is still theoretical and probably won't work for decades. One idea that seems far-fetched but has some serious backing is laser-pushed sails. The basic idea is to put a sail in space and use powerful lasers to push it along. In fact, the Breakthrough Starshot initiative wants to use this method to send a tiny probe to Alpha Centauri, the nearest star system to ours. But until that happens, rocket engines will continue to push the boundaries of what's possible, allowing us to explore the solar system and beyond. But until that happens, rocket engines will continue to push the boundaries of what's possible, allowing us to explore the solar system and beyond. From hot gas to deep space, they keep pushing us forward. If you enjoyed this, hit like, subscribe, and stay curious.